Hello friends, my name is Hari Krishna. I am your science teacher. Today we are going to discuss about a topic from chemistry, chapter 1 of 10th class. Chemical reactions and equations is a chapter. In this particularly we are going to discuss about that subtopic called decomposition reactions. Let's see that. So decomposition reactions are the reactions in which one compound breaks into two or more compounds. So when one compound splits into two or more simpler substances, such reactions are said to be decomposition. Decomposition means breaking. Easily we can tell. In fact, it is opposite to combination, because in combination, two or more chemicals combines and forms one chemical. But in decomposition, one chemical only breaks into two or more chemicals. So it is decomposition is opposite to combination. In fact, to decompose anything, we need energy. So all decomposition reactions are endothermic. Exceptions are there, except decomposition of vegetable matter into compost. Digestion of food is said to be exothermic. So vegetable matter, whatever the waste is there in our kitchen, it can be converted to compost. It will be decomposed into compost. Still it is decomposition only, but it is not endothermic, it is exothermic. The reason is they release heat. Even digestion of food, when you take any food contains macroscopic substance. When it's break into microscopic substances, it releases heat. So it is exothermic. So these two, vegetable matter and digestion of food, both are undergoing decomposition only, but they are exothermic but not endothermic, because the reason is they release heat. And these decomposition reactions are three types. One is thermal decomposition, next one is your photolytic decomposition, and next one is electrolytic decomposition. Thermal, photolytic and electrolytic recommendations. Electrolytic decompositions. So let's each and everything. First one is thermal decomposition. Thermal means heat, very simple. So the reactions, the decomposition reactions which happens by applying heat is said to be thermal decompositions. Very simple. So let us take for example calcium carbonate. When we take calcium carbonate and we heat this, means when we're heating this, one of the oxygen from CO3 goes to that calcium and forms calcium oxide, and CO2 is left. And CO2 is a stable compound, so it loses one of the CO3 is an anion, loses oxygen to calcium, converts to CO2. That is how we get calcium oxide and CO2. It's a decomposition reaction because one compound is breaking into two or more compounds. So it is a decomposition reaction only. Yeah, let's take one other example. Yeah, next one is decomposition of lead nitrate. So how this lead nitrate is decomposed means we can remember like this. So this one, so let's see the decomposition of lead nitrate. So remember, it's two molecules we have to take. I am telling shortcut how to remember. Okay, it's not originally how it breaks. For remembering without by hearting that answer, how to write answer. That is why I am telling like this. So lead nitrate is there, two molecules are there, so Pb and O3. Like this, Pb and O3 twice, two are there, two molecules. So from one NO3, remove one oxygen, converts to NO2. Remove one oxygen, we get NO2. Because NO3, remove one oxygen, we get NO2. Remove one oxygen, we get NO2. So totally how many NO2s are there? 1, 2, 3, 4. 4 NO2s are there. Next, lead combines with oxygen. So when they're combining, lead charge is +2, oxygen charge is -2. It's valency 2, it's valency 2. Crisscross if you do that. Pb2O2, that means multiples are there, we can cancel. The final formula is PbO. So PbO is there. Means how many are there? Pb's, 2 Pb's are there. So write 2 Pb's. That means 1 Pb combines with one oxygen, 1 Pb combines with other oxygen. So what is left finally? 2 oxygens. So O2. So that means when you heat lead nitrate, we got nitrogen dioxide, lead oxide plus oxygen gas. The colors are very simple. Lead nitrate is white color, lead oxide is yellow color, nitrogen dioxide is a brown color. It's a gas form. The brown gas goes out. When a gaseous substance are there, show arrow mark up. I hope this decomposition is clear. Similarly, we can go for decomposition of FeSO4 also. FeSO4 actually possesses 7 water particles. Okay, because it when FeSO4 exposed to the air, it attracts water particles. Just on slight heating, this water goes off. Actually, the color is green color. On heating slightly, it becomes colorless. This colorless substance, on further heating, we got chemicals like this. Now let's see how to remember this. Take 2 molecules. FeSO4. Similarly, we have other FeSO4. Okay. From this 1 SO4, remove 1 oxygen, converts to SO3. From other SO4, remove 2 oxygens, you get SO2. Okay. So now this iron combines with oxygen, but iron charge is here +3, oxygen charge is -2. So it's valency 3, it's valency 2. Crisscross, if you do that, Fe2O3. That means 2 irons combines with 3 oxygens. That's it. Fe2O3. Remaining substance are SO3 is a gas, SO2 is a gas. Its name is sulfur dioxide. Its name is sulfur trioxide. Okay. This is how the decomposition reactions happens. All these are said to be thermal decompositions only. I hope it's clear to you. Let's go to next decomposition. It is photochemical decomposition or photolysis decomposition. Okay. Photo means light. Suppose when you take example of AgCl, silver chloride, on exposed to the sunlight, it breaks into Ag and chlorine. Very simple reactions. Similarly, chemical like AgBr, silver bromide, on exposed sunlight, just break the silver and bromide, Br2. Similarly, H2O to hydrogen peroxide, when it is H2O2, which means hydrogen peroxide. Its name is hydrogen peroxide. Hydrogen peroxide also, when exposed to the sunlight, just it breaks as H2 and O2. So 2 molecules are there, so it breaks as H2O plus OH. Means it's like this. H2O2 gives rise to, just remove 1 oxygen. 1 oxygen comes out from this. Like this, we have 2 H2O2s because we have 2 molecules. So we have other H2O plus 1 other oxygen. These two combines and forms O2. That is where 2 H2O plus 1 O2 is there. That is how H2O2 breaks. As the AgCl and AgB are very sensitive towards light, so they are stored in black color bottles. And these are the chemicals that are used on the black and white photography. Films, we call that as films. In olden days, we have films in camera. For that camera's films, we use this. Okay. I hope it's clear. Next type of decomposition is electrolytic decomposition. So next type of decomposition is electrolytic decomposition. So the decomposition which occurs when you pass electricity is said to be electrolytic decomposition. If you take water, actually it is 2 molecules here. If you take water, if you pass electricity through that, it breaks as H2 and O2. How it happens, let's see. So when you take beaker and you take water and you take electrodes which is made of graphite and connect to the wires to the battery. So when you take a beaker with electrodes connected to the wire, one is positive terminal, other one is negative terminal. So it is negative terminal, this is positive terminal. We have a solution called water. This water breaks as H plus and OH minus. So let's see the electrolysis of water. So when you take a beaker, when you take a wires and connect it to the battery like this, battery has 2 terminals, negative and positive. We have water here. This water possesses 2 types of ions. One is H plus ion, other one is O minus 2 ions. These H plus ions moves towards negative terminal, which means it is cathode. As cation plus is attacking, so it is cathode, but it is connected as a negative terminal, remember that. So H plus goes there, accepts electrons which is given by the battery, converts to hydrogen. Whereas oxide ion, which has negative charge, moves towards positive. As negative is attacking, so it is anode. Because it is positive terminal attracts negative. A negative means anion, so it is anode. O minus 2 goes there, gives out 2 electrons, converts to oxygen. But practically, one oxygen won't be there. 2 oxygen gas will be coming out. So, 2 oxide ions, that means 2 oxygens, means 2 oxygen atoms, 1 oxygen molecule. How many electrons are coming out then? 4 electrons. So, now electrons, whatever is at the cathode, must be equal to electrons at anode. So, here also 4 electrons. That means hydrogens must be 4. That means 2H2. So these are the different types of gases. At the cathode we get H2, at anode we get O2. The ratio of these gases are 2:1. That means hydrogen amount is more when compared to oxygen amount, because in water only we have 2 parts of hydrogen when compared to 1 part of oxygen. That is why hydrogen amount is more when compared to oxygen. That gas amount is more at a cathode. Similarly, we have second example like Al2O3. Similar to this aluminum, Al2O3 also breaks as aluminum atom as well as oxygen gas. All these things happens when you pass electricity only. So it is called electrolytic decomposition. I hope up to here it's clear. Let's solve some questions. Write one equation for decomposition reaction where energy is supplied in form of heat, light and electricity. Indirectly is asking definitions only. Thermal decomposition, one example. Photolytic decomposition, one example. Decomposition by electricity, electrolytic decomposition, one example. Any example you can write. It's indirectly definitions only. Remember, when writing equations in this chapter, we need to use physical states and with their names. Names are compulsory, physical states are compulsory. Without that, you cannot do anything. You won't get full marks at all. Okay.